Hello viewers, I discussed today that in Hilbert space the inner product is jointly continuous. That is, if we are writing xn as a sequence, if the tending to x and yn tending to y, that jointly imply this xn yn that tending to xy, x dot y. All are dot product or scalar product. Xn dot yn tending to xn dot y. We have to prove this result. And in other words, we can say this inner product is jointly continuous. This statement is also written as inner product in a Hilbert space is jointly continuous. We have to prove this result. So, for the part of proof, here we have simply for the part of proof we are taking in this way. At first we are taking xn dot yn minus x dot y, and if we are proving this tends to 0, then our object will be successful. So before the part of proof we are adjusting a few terms. This term will be just for addition alternations. We are taking in this manner xn dot yn minus if we are take there's a subtraction xn my dot y plus xn dot y, that is a subtracted xn dot y plus xn dot y plus x dot y. In this way we are taking, because our object will successful if we follow this result. At first we are using the property of linearity here. This property will be xn dot here yn minus y, and another property, that is here it is a plus minus and here it is minus sign, just a mistake, and here we are taking xn minus x dot y. So in this way we are representing this result now, and this condition is by linearity property. It is by linearity property of inner product. Taking in this way, and which is clearly less than equals to mod of plus, that is mod of a plus b or alpha plus beta less than equals to mod alpha plus mod beta. In this object we are writing, so xn dot yn minus y, and taking mod of this plus mod of xn minus x dot y. We are using in this way. Now let's watch, and that will be less than equals to norm of xn, norm of yn minus y plus norm of xn minus x into norm of y. This is by Schwarz inequality. And it is clear that we are using as xn tends to x and yn tending to y. Therefore, so we can write it as norm of this is called here this two result xn minus, and this result for n tending to infinity, this must be the conditions. So this is also tending to 0 and norm of yn minus y also tending to 0 as this is and as n tending to infinity. So both of these criteria satisfied. This will be tends to 0 and therefore as this tends to 0, so finally we can say this mod of xn dot yn minus x dot y that tending to 0 for n tending to infinity, that is xn dot yn tending to x dot y, and we finally go to our desired result. So in this way we end our discussion today. If you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.